Okay, I'm almost at the end of our boat monitor, so really just going to have a look at the UI and Angular side of things for this before the final video, which will be where I actually install it in the boat, but that's probably a couple of months away based on the temperature. So here's the checklist for our boat monitor from our checklists, and let's look at some of the things still to do. I want to add a scaling function for data acquisition, so and this is something I'll run back into the ourLora code as well, so that the data coming in can be converted to a different scale. So maybe I want to capture things as centigrade rather than Fahrenheit, so convert a value coming in. I want to add some icons to the views, so that when I display my views, I can see them as icons. So give me an example of that. So at the moment, when I go into my views, it shows, in this case, I've got 6 views available. But it'd be nice if there's a little icon in here just to pick out which one I really want. So like battery voltage, have a battery and a voltage symbol or something. Humidity, have a % sign and a water droplet, those sort of things. So it just makes it easier to pick out which one I want to click on. I want to add a scaling function to views, so same sort of idea as acquisition, but I may acquire data, say again as Fahrenheit, but want to display it as centigrade. I might want to do this as an expression, so I could actually put a formula in. So again, in the case of Fahrenheit to centigrade, I need to subtract a value and then multiply by a value. So just being able to enter a general formula would be a good way to go for that. I want to refresh data for views. So I was finding my views wasn't correctly updating the graphs when I click on them. Sometimes it didn't seem to do anything, or is getting behind for some reason. So I need to really just do a debugging exercise to see what's happening there. I want to add a event trigger limit. So for example, if I have a trigger coming through as an alert, say when my battery turns off in the boat, I don't want it to come through every hour. So I want to set some sort of limit where if it's already sent that trigger, maybe don't send it again, or if there's more than X number in a certain number of hours, only send one and then wait for that time to expire before it sends another one, just so I don't get bombarded with a whole lot of messages. Other than that, just need to test the hardware in the case, install in my boat. Again, it's going to be a couple of months before I get warm enough and pull the boat out to do the actual installation, and then roll everything back into the ourLora and FBM starter that changes that I want to keep for other projects as well. So let's see how many of these I can get done. Hopefully mostly in this video. I won't go into the details of the code unless there's something interesting I'm doing. So for example, the scaling function for views, where I'm going to use an expression, that may be an interesting one, so work out how to do it. Okay, one checklist item was the setup boat monitor definitions. As you remember, our boat monitor was derived from the ourLora project, and that had the functionality inside the application to set up sensors and devices and device types and things. So I needed to set that up for my boat monitor device and all the sensors I've implemented, and I basically did that by setting up a device type for our boat monitor. And then these are all the various sensor definitions for that device type. So for example, this lithium-ion battery, just like an ourLora, I define a name for it, the unit of measure, and I always pick up latitude and longitude for every sensor, and then the actual name of the data coming in on the body to my application in the payload field, so lithium-ion voltage in this case. So that defines and ties the data coming into the ourBoatMonitor backend to the actual specific sensor. And I basically did that for all the different sensors set up. As well, I had to set up applications. So there's only one application called Boat for a boat monitor, and in there I set up any triggers and views that I want associated with that monitor. So I need to say which devices are in scope, what triggers I want, and what views I want to create. So these are the various views here, and for example I have a trigger that fires when the battery is disconnected. So if it looks at the house battery sensor, so getting the voltage of the house battery sensor, and the value is between -1 volts and 2 volts, then that's saying that the house battery must be disconnected. The action will be to send an email that the battery's disconnected, and then we'll have a look at some of these fields which are added on for some other checklist items I want to cover. And for example, the other thing I want to do is have views into various things. So again, house battery, the sensor that I want to cover by this view, how to show that view. So setting this up for all the various views for each of the sensors is what I had to do. And then we'll have a look at this viewer icon thing, which is one of the additional checklist items. Next item was to add this view icon. Just a note here, this item here, I'm not doing add scaling function to the data acquisition. I didn't really need that in the end, so I'm not doing it. This add scaling function to views kind of covers everything I need in that area. Okay, so let's have a look at this. Add a view icon. So basically what I wanted to do was, when I look at views, rather than just having text here, have little icons to indicate what the views are for. So for example, house batteries are a little battery, temperature shower thermometer, and so on. The way I did that in the user interface was under the view. So let's have a look at this house battery. I have this little button which allows you to upload a small icon. It's going to be sized to 32 by 32, so you might as well size it to that before you upload it, and it can't be very large. I want the rendering to be fairly fast, so 20K. And the way I did that in the code was on the view model, I added this icon URL, which is basically a string pointing to the firebase storage, which contains the actual icon file. And then in the view component in the HTML, I just followed the code that I actually already had for the user component for uploading people's icons that they wanted to have associated with their user. So really this just follows that same code and does a file upload for the icon, and then down in the code on upload file, this is the code that actually gets the file and puts it into the firebase storage, and also calls this get storage URL, which gets a public version of the URL so that anyone who has that URL can display it, and that's how the icon actually gets displayed and is shown on my views. Next piece of functionality was to add scaling function for views. So this is so I can do things like convert the way data is held internally to how it's shown on the view. So for example, if we look at temperature here, you see I'm showing that in Fahrenheit, but the data is actually held in the events as centigrade. And so what I'm using when I look at the temperature view, I'm offsetting that by 17.77, which is the conversion from centigrade to Fahrenheit, and then scaling that whole thing by 1.8. It does the offset first, so that's why it's 17 rather than 32. So it's the ratio of 1.8 of 32 is 17.77. And so that scales for this view, even though internally it's held in centigrade, it shows it as Fahrenheit. And then I'm doing the same thing here for air pressure. So internally I keep track of air pressure in just pascals, and then I use a scaling factor to convert that to inches of mercury, which is kind of the more traditional US way of showing things. And the way that was done is, again, in the view model, I added two properties to contain offset and scale, and they're optional. You don't always want to scale or offset the basic information in the views. And then in the actual viewer, when it's collecting the data for that particular view, if it has an offset, then it applies that offset. If it has a scaling factor, then it multiplies whatever the value is by that scaling factor as well. And otherwise the code's the same as before. It just uses Google Charts to show the resulting values which have been offset and scaled. So another thing I wanted to do is to do this add event trigger limit. So basically I didn't want to be able to didn't want to send the same action over and over again. So say if my house battery was low on the boat, I check for it every hour, so I didn't want to always send an email to the users every hour, because people will get sick of that, and it'll probably be a day or two before I get up and see what's happening on the boat in that case. So I really only needed to send that that action for that trigger probably once a day is more than enough. Same sort of thing for SMS. I don't want to bury people in SMSs. If, say, I've got an SMS saying that the water level's high, probably, once every 6 hours is plenty for that. But people will get annoyed if I send them a SMS every hour for the same alert. So that's the idea behind here, is put some sort of limiter into the actions associated with a trigger. So what that looks like in the boat monitor. So let's have a look at something like this: battery disconnected. I've added these fields tied to the action. So to send a mail, I've put this limiter in, or action delay. So that's the minimum time between actions. So if that action's already been performed, then it's going to wait 12 hours before it performs it again, even if it's been triggered in between. And to help with the implementation, you'll see I've also added the time that the last time that action was performed, and that's what I'm checking against in the code to see whether it's time to send the action again. What that looks like in the code. So again, in the trigger model, I've added these two properties. One is the delay between actions. That's a number of seconds between actions. So 3600 seconds would be 1 hour to wait before performing the same action again in response to a trigger. But that can be set to anything. And then that's that last action timestamp, so when that action was last performed. And then that's all managed down in this case in the firebase functions, so the back end. And this code was already in ourLora to do the triggering of an action. So if a trigger is active and it matches the sensor and the sensor data, then it calls process trigger. And what I've added into this process trigger is this suppress action flag. So if the delay between when it last saw that action and the current action, so the seconds diff, is less than the delay between actions setting for that trigger, so if, say, it's less than an hour, if that's what the delay is set for, then I'll turn on the suppress action flag, and so it won't perform the actual action, which is the way the thing behaves. That's all working, and the other nice result of this is I also get the time that the action was last performed for a trigger shown on the trigger page now. One other thing I checked on before finishing the project, I wanted to see how fast the lithium-ion battery was discharging and whether it made a difference if I flashed LEDs or not. So this is the test that I performed to do that. Okay, let's have a look at everything connected up. So I've got our bilge order level switch assembly all connected up here, and you see here we've got a terminal connector that provides the various resistance from the switches to the ourBoatMonitor box. And at the moment I've got the power turned off. I've got a discharged lithium-ion battery, and at the moment I've got it unplugged. So let's turn on the power. So at the moment no power coming in. I turn that on. 12 volts coming in as though it's connected to the house battery, and we see it start up and the PyCom going through its normal sensor routine. So it's getting the GPS coordinates at the moment. That's the red blinking. Once it hooks into a satellite, then it'll change to green blinks while it gets some readings off the GPS. Let's plug in the lithium-ion battery. So if the lithium-ion battery is discharged, then this little red light turns on, indicates that it's charging. Once it's charged up, that light will go off. But otherwise everything's working. We've got the right power, and if I look at the amp meter on the power supply, at the moment it's drawing about 0.3 amps, so that seems to be the maximum amperage it uses. If it needs to recharge the lithium-ion battery, it drops way lower. If it's not running, and it doesn't need to charge the lithium-ion battery. So it all looks good. Okay, last couple of weeks I've been doing some lithium-ion battery tests to see how long it'll last, and also to test if I turned off the LED blinking whether it'd last longer. So these are the two tests. So this first test here sort of starts there. I'll remove those spikes. Starts at about 4.1 volts and stops working about 3.3 volts in this first run, and this is with the LED lights running. And then the second test I did starts up here about 4.15 volts, and this one actually stopped at 3.5 volts. So those are the two rundown tests, and I'm going to extract this data. So I'll go into table and I'll get a copy of all this data. So I put all the data into Excel. You see the two lines here shown using the LED and not having the LED running while the battery's discharging. Little difference in the discharge rate, but really not enough to make me want to keep going with not turning on the LEDs. So both cases it took about 80 hours or just over 3 days to discharge, which is more capacity than I really need anyway for a backup battery, when mostly the boat monitor will be running off the house battery. So that's it for the boat monitor project. It's all working, ready to go in the boat. It'll be a couple of months before I actually put it in, so once it's installed and I've been getting some readings from when it's sitting in the dock, I'll do one more video just showing the final results.